Hello everyone, I am Pal Bhardwaj, the Growth and Marketing Officer at Earthspace Labs. Based in Delhi, India, our advanced research lab brings together the world's best science and artificial intelligence to solve humanity's biggest challenges. Right now, our focus is entirely on climate change induced disaster predictions and early warning systems. Today, we are glad to walk you through a detailed tutorial of our very first tool developed in this direction, DebriMaps 1.0. This tool has been built to align closely with the urgent safety and planning needs of populations living in the regions facing some of the highest climate induced disaster risk in the world. DebriMap 1.0 is a local, user request based dashboard. It leverages the most advanced science and satellite technology available today to provide dynamic mapping of debris flow susceptibility in user specified areas. Instead of one size fits all solutions, the tool relies on specialized physics based and statistical modes tailored specifically to user chosen area of interest. Furthermore, these models have been thoroughly validated using extensive historical data from past debris flow events. To prioritize human life and infrastructure safety, the tool utilizes an over-conservative approach. What this means is that the model predicts the maximum potential danger of a debris flow in any given area, ensuring you are always planning for worst-case scenarios. Please note that this tool is strictly confidential. It is not intended for public use and is authorized exclusively for designated scientific expert organizations. Because our planet is changing rapidly, WMAP is a dynamic tool. The terrain and climate shift constantly throughout the year, meaning these maps and their validity expire at the end of each rainfall season. Every year requires fresh analysis and remodeling of the susceptibility boundaries to stay accurate. For a high-level overview of these methodologies used, you can reference our accompanying technical report. Before we begin the step-by-step user walkthrough, we must emphasize our scientific disclaimer. DebriMaps 1.0 is a diagnostic susceptibility tool. It does not assert that these slopes will inevitably fail. However, it does present high probability scenarios of debris flow inundation. Based on current geographical variables, the findings confirm that these areas are geologically susceptible to debris flow under specific water saturation conditions. With that understanding, I will now pass the mic over to Harshit Singh, our core software and operational engineer, who will take you step by step through the tool. Harshit, over to you.
Thank you, Payal. That was a great introduction. Hello to the viewers who are watching this demo. I am Harshit Singh, an MTech student in DTU who is the core software and operations engineer behind this project that is on the showcase today. I have worked with Ms. Kamini, who is the founder of this research lab, Earth Space Labs, here in DTU, covering the technical side of this project, bringing her research work to the front end. I would now like to share my screen. To access our product, navigate to earthspacelabs.com, scroll down, and click on the tool link. At a first glance, you will see our beautiful globe and our sign-in panel on the right. As a user, you will be provided with credentials from us which you can use to sign in. Once we are logged in, the dashboard will have the following: a list of maps that you have purchased, the base map editor, which will have two modes to select from, the SRE satellite default and an OpenStreetMap view. As we select a map from the list, we can see the raster has been draped over the globe. There will be an opacity control slider. As, a, as the opacity control slider will be helpful in viewing colliding boundaries and studying points where the debris flow values are high. With this, we will be able to view the disaster exposure area. We can identify the assets, houses, land parcels which are falling in a debris flow susceptibility zone. The basic usage is left click to pan, zoom in with scroll wheel up, zoom out with scroll wheel down, and control plus left click to enable the raster in the 3D mode. So currently, this project has been focused on delivering the core needs of the users by covering the raster maps and their effective draping over the globe. In the near future, we will be adding more features to enhance the user experience as they get to tinker around with more tools from the GIS sandbox. Since this project is running on the lowest compute load possible for a heavy geospatial project that depends on Jira libraries, we have kept the features minimal for the time being. We hope to bring more features for this product in the future.